If the first and last terms are perfect squares, check this. Is the middle term double the product? If yes, it's a perfect square. Let's see the first example. So, as you can see, our first and last terms are perfect squares. X squared is a perfect square and 25 is a perfect square because the square root of 25 is an exact real number. It is 5, right? So we can pair them. So we can say, with using the formula, well, x squared is just x squared, right? Then a squared must be equals to 25. So if we're trying to find a, what we can do is take the square root on both sides, as we have seen before with other types of factoring, and we're gonna get that a is equals to 5. And that easy, we can just pull up that x squared plus 10x plus 25, it's x plus a squared, with a being 5. So x plus 5 squared. And we are done. Let's see this other example. Let's start by checking if the first and last terms are perfect squares. So, the square root of 4y squared. The square root of 4, we know it's 2. The square root of y squared must be just y. There we go. That's a perfect square. Now, the square root of 9 must be equals to 3. So 9, it's also a perfect square. Now, it's the middle term, 12y, 2 times the product between these two. Let's check that. 12y must be equals to 2 times the product between 2y and 3. So let's see. 2 times 3 will be 6. So we have 6y times 2. It's 12y. So that makes sense. It's a perfect square trinomial. So we can use the formulas on top. In this case, our x has a little change. And instead of x, it's going to be 2y, right? So we pull up 2y. And then since here on the second term we have a negative, we are going to use a minus on the factored form. So we have 2y minus, and the value of the square or the square root of the last term is in this case 3. So 2y minus 3 squared. And that's it. How can we see if our answer is correct? Well, let's see it. We can just do 2y minus 3 squared is exactly the same than 2y minus 3 times 2y minus 3, right? So let's try to distribute it. Let's see. 2y times 2y must be equals to 4y squared. 2y times negative 3 will be equals to negative 6y. Negative 3 times 2y is again negative 6y. And negative 3 times negative 3, it's positive 9. And if we combine negative 6y with negative 6y, we can rewrite it as negative 12y. So we're going to get 4y squared minus 12y plus 9. And there we are. We have exactly the same expression than in the beginning. Here you have two practice problems. You can pause the video and see what you get. And of course, here you have the answers just to check. So here is the key for identifying perfect square trinomials. I call it the perfect square test. First and last terms are squares and the middle is double the product. Let's see this expression as an example. 9y squared minus 12y plus 4. Let's start by checking if the first and last terms are perfect squares. How? Well, we can just take the square root and see if we get an exact expression. So square root of 9 is 3, and square root of y squared is y. Here it is. First term is a perfect square. We got it. Now, last term, square root of 4, well, that's 2. Also a perfect square, because 2 squared is 4. That's it. Now, let's check if this term on the middle is double the product between these two. So we're gonna do 2 times the product between them, which is 3y, 2 times 3y, times 2. So 3 times 2 is 6, times 2 is 12, times y, well, just 12y. There we go. That's the term that we have here in the middle. It's a perfect square. So now we can just write it in its factored form as 3y, which is our first square, minus, because here we have a minus, 2, which is our last square. 3y minus 2 squared. And that's it. Thanks for watching the whole video. Don't miss our next one. Stay tuned. Next one will be about evaluating the most common trinomials with leading coefficient of 1. See you in the next one.